In this video, we're going to be solving this problem on function composition in Algebra 1. The problem statement says, let the function p of x equals x squared plus 2, q of x equal 3x to the fourth minus 1, and r of x equals 7x to the fourth minus 5x to the third minus 6x minus 2. Find p of q of x plus r of x. So we have the function definitions copied down here of all the three functions. So in order to solve this problem, we're going to need to figure out each of these two function values here, the composition p of q of x. And a function composition is essentially whenever we have the input of one function being put as the input into another function. So in this case, the result of q of x is being input back into p of x to get a totally separate result. So let's start off with finding out what p of q of x equals. So here we're going to work from the inside out. So we start off with q of x. So what is that? Well, all we have to do here is just use the definition of the function q of x and plug it into p of x. We don't have any values for x here. We're just dealing with the definitions themselves. So we know the definition of q of x is 3x to the fourth minus 1. Then we can plug that back into p of x, where the x in the definition for p is represented by 3x to the fourth minus 1. So this x right here, the one that's being squared as the input of the function p, that is the same as 3x to the fourth minus 1, because we're composing these functions together. So if we were to substitute q of x into p of x, it would look like this. P of q of x would be equal to, in parentheses, 3x to the fourth minus 1 squared plus 2. So this is our p of q of x. We can then expand this product here just to get a simplified result. This is the same as saying 3x to the fourth minus 1 times 3x to the fourth minus 1 again. So we use the distributive property, starting off with the first terms, we get 9x to the eighth. Then the outer terms, we have minus 3x to the fourth. The inner terms, minus 3x to the fourth again. And finally, plus 1 for the last terms, which is going to give us 9x to the eighth minus 6x to the fourth plus 1. So that's our simplified p of q of x. Then we must add 2 because the function definition for p of x states x squared plus 2, which gives us this whole thing, and then plus 3. So that's our completed simplified function definition. Okay, so then we have to add r of x. So we're taking this result here and we're adding the definition of r of x to that. Okay, so we have our definition of r of x. We know is 7x to the fourth minus 5x to the third minus 6x minus 2. So all we have to do is just a simple algebra addition problem here. So we're going to have our 9x to the eighth minus 6x to the fourth plus 3. And then plus the function r, 7x to the fourth, minus 5x to the third, minus 6x, minus 2. So then all we have to do here is combine like terms. So we've got x to the fourth here. We've got just 9x to the eighth on its own. Don't combine that with anything. Minus 6 plus 7, we're going to have positive 1 there at that point. So that's plus x to the fourth. Okay, then we have just minus 5x to the third, no other terms of that type. Then minus 6x, only term of that type. Then 3 minus 2, that's going to give us plus 1. And there we go. We have successfully solved the problem. That's our final result right there. 9x to the eighth plus x to the fourth minus 5x to the third minus 6x plus 1 is our final simplest form solution to this problem on function composition. So basically what we had to do here is first evaluate from the inside out when it came to p of q of x, find the value for q of x, plug that into p of x, then get a result, and finally add it to r of x. So that's really all we needed to do here for this function composition problem under Algebra 1.